All right, 4.4, compound inequalities are ORs again. So our normal ORs are separate and go in opposite directions. But these are special cases. It doesn't mean you won't have normal ones, but we do have some special cases. So we solve both halves as usual. We sketch them both on a number line as usual. If they point away from each other like this, then that's the way they're supposed to go. But if they don't, you have two options. If they point towards each other like an and, if they look like an and, oops, if they look like an and, but they're separated by the word or, then it's all real numbers because it's an or, and what they're doing is one's going this way all the way, and one's going this way all the way. So it's considered all real numbers because it would cover the entire number line. They don't stop like the words and do. They go all the way. However, the other option is if they point in the same direction. Then you pick the region that covers more of the area. So this is one of those where you're graphing them and one's headed over this way, and then you get your other one, and goodness gracious, it goes all the way. So it's different than the ands because the shaded area wants to begin from where it started and all the way, where the ands that were a special case only wanted this point and forward. But this is different. This is an or. And here we go. So number one, we definitely have ors. They are separated with the word or. So we'll do them one at a time. First thing, 6 plus 6n is greater than negative 12, so we'll subtract 6 on both sides. Hopefully you're getting really good at these solving equations and inequalities. So we have 6n is greater than negative 12 minus 6 is a negative 18. Divide by 6, divide by 6. And we have n is greater than, a negative divided by a positive is a negative 3. There's one of them. Second one, negative 5n minus 6 is greater than or equal to 31. So the opposite of subtracting 6 is to add 6 to both sides. And that looks like a 4. That goes away, and we've got negative 5n is greater than or equal to negative 31 plus 6 is a negative 25. Divide both sides by negative 5 by negative 5. And remember, when we divide by a negative number, we have to change the direction of the inequality. And now we're left with n is less than or equal to negative divided by negative is positive, and 25 divided by 5 is 5. So these are our two inequalities. Our most important numbers are negative 3 and positive 5. N is greater than negative 3, so an open dot going towards the positive numbers. And n is less than or equal to 5, so it's a solid dot, and this one's going in that direction. So when they overlap and they are ors, it's called all real numbers. All real numbers, because it covers all of the number line. Okay, second example. Once again, it's an or. We have two inequalities. 10x is greater than negative 50, so all we have to do is divide by 10. So this is a quick solving. X is greater than or equal to, a negative divided by a positive is negative 5. So there's one of them. X divided by 2 is less than 1, so this is also quick. If it's divided by 2, the opposite is to multiply by 2. The 2's go away, and we're left with x is less than 1 times 2 is 2. So our most important numbers are negative 5 and a positive 2. X is greater than or equal to negative 5. So solid dot, because it's equal to, going in that direction. X is less than 2, so it's an open dot, and it's going in the opposite direction. So once again, they cover the entire number line. So this is also and all real numbers because it is an or and they overlap. All real numbers because it is an or and they overlap. Examples 3 and 4. And I'll get rid of my work that came down with me. I don't know why. All right, here we go. 2 quick ones. We've got p divided by 9 is greater than or equal to -1. The opposite of dividing by 9 is to multiply both sides by 9. The 9's go away, and we have p is greater than or equal to -1 times 9 is -9. Second side, 10p is greater than or equal to 20. So we'll, instead of we're multiplying, we will divide by 10. And that gives us p is greater than or equal to 20 divided by 10 is 2. So on our number line, our most importance are -9 and +2. P is greater than or equal to -9, solid dot, going towards 2 and higher, and P is greater than or equal to 2 is also a solid dot, and it's also going towards the more positive numbers. So in this case, our solution is this one because it covers the most area, and includes and picks up the other inequality along the way. Last example, we've got 5 minus 4x, so the opposite of adding 5 or having a positive 5 is to subtract 5 on both sides. Those go away, and I've got -4x is less than or equal to 20 minus 5 is, or 25 minus 5 is 20. Divide both sides by a -4, divide both sides by a -4. Remember, we're dividing by a negative number. We have to change the direction of the inequality. Positive divided by negative is a negative, and 20 divided by 4 is 5. So we've got x is greater than or equal to -5. Other side. Let's see, 6x minus 3 is the opposite of -3 is to add 3. And now we have 6x is greater than -15 plus 3 is a -12. Divide both sides by 6. And we have x is greater than, positive divided by negative is negative, and 12 divided by 6 is 2. So our most important numbers are -5 and -2. Make sure you get them in the correct order, or you're going to have the wrong answer. X is greater than or equal to -5, so solid dot on -5 going towards the positive numbers. And then x is greater than -2, an open dot on -2, and also going towards the positive numbers. Remember, this is a special case for an or. So on the special case ors, unlike the ands, you start from the very most covering dot. And in this case, it's this one. That covers the most. If it was an and special case, it would start from the place where they finally intersect. But this is an or, so it's the one that covers the most distance, All right, couple more. Let's quickly do these. M minus 4 is greater than 1, so we will add 4 instead. Add 4. And we get M is greater than or equal to 1 and 4 is 5. Or we have 4 plus 5m is greater than 34. So the opposite of 4 once is to subtract 4. And we have 5m is greater than 34 minus 4 is 30. Divide both sides by 5. And our second inequality is m is greater than 30 divided by 5 is 6. So our most important numbers are 5 and 6, nice and close together. M is greater than or equal to 5 is a solid dot going towards the positive numbers. M is greater than 6 is an open dot, but going also towards the positive numbers. This is a special case or. So ors cover the most distance. the most distance. So the most distance is this guy. Last but not least, here we go. 3 minus 6x is greater than or equal to negative 33. The opposite of a positive 3 is to subtract 3. We've got negative 6x is greater than or equal to negative 33 minus 3 is a negative 36. Divide both sides by a negative 6. Remember, we just divided by a negative number. Flip that inequality around. And a negative divided by negative is a positive, and 36 divided by 6 is 6. Second one. Well, the second one, I want to just include this little negative 1 here so we get everything done correctly. So the opposite of subtracting 6 is to add 6 to both sides. And we're left with negative 1x is less than or equal to. Negative 1 plus 6 is a positive 5. We don't want a negative x, so we need to divide by negative 1, which changes the direction of the inequality. And 5 divided by negative 1 is negative 5. So our two important numbers are negative 5 and positive 6. We've got x is greater than or equal to, so a solid dot, then negative 5 going towards the positive numbers. And we have x is less than or equal to positive 6, so another solid dot, and it's going towards the negative numbers. So this is an OR special case. It's an OR special case, and ORs take up the most space. So it's the entire number line, or all real numbers. And that's it. Have good luck on 4.4 special cases of